Welcome back. In this video, we talk about moment of a force about a given axis. In the previous video, we have seen that the rotational effect of a force vector is quantified by a moment vector. In order to define a moment vector, we need a force vector, a point of application, and a reference location about which moment is calculated. Let R be the position vector of location A with respect to point O, and F is the force acting on the body where A is the point of application. O is the reference point at which moment is calculated. So we know that the moment vector M is defined as R cross F, the cross product of R and F. Now consider the direction of moment vector for a given R and F. Moment vector will be perpendicular to both F vector and R vector. So you can imagine that you are turning a screw from R to F. It will be giving an anti-clockwise moment. So we can see that it is directed towards the unit vector k. And note that in this case, the force is acting upward to the point A to the rigid body. Now imagine that the force vector is acting in the opposite direction at the same location A. So this will generate a moment vector which is perpendicular to both R and F. But in this case, from R to F, we can see that it's a clockwise moment. So the clockwise moment will generate moment vector in the minus A direction in this case. Now let us talk about moment of a force about an axis. Before explaining this, let us review the concept moment of a force about a point. Consider the force F acting on a rigid body at location A, whose position vector is given by vector R. Let O be the reference location about which the moment is calculated. By definition, as we discussed previously, moment of force vector F is R cross F, which is about the point O. Now, let us extend this idea to moment about an axis. Let AA is the axis chosen for this purpose. Now, the moment of force F about an axis AA is mathematically defined as UA dot R cross F. And you already know what is R cross F because that is a moment of force about point O, which is a point in that axis AA. Now, the additional term UA is the unit vector along the axis AA. Now, note that this is a dot product of two vectors. One is a unit vector along the axis AA, and the other one is R cross F, which is the moment of force about a point O in that axis. So this gives you a scalar quantity. So we now realize that moment of a force about a given axis is a scalar, which is the dot product of UA, which is a unit vector along the given axis, with R cross F, which is the moment of force about a point in that axis AA. Now consider a problem calculating the moment of a force about a point O as well as calculation of moment about a given axis. The problem is you have given a bracket fixed at O, a bracket OB fixed at O, and the location of B is given as indicated. and force is acting at B, which is also given. So the coordinate axis I, J, and K are fixed at location O. Now let's do the first case, calculating the moment of force about O. So by definition, we know that moment of a force is R cross F. So we need to find out what is R and what is F in this case. F is given as 10I plus 30J plus 20K. Now what is R? So R is the position vector of point B with respect to O. So from the geometry, we know that B is located 3 meters in the minus K direction and minus 1 meter in the minus J direction and 2 meters in the positive I direction. So we can write the position vector of B as 2I minus J minus 3K, because 2I means it is 2 meters in the positive I direction. Minus J means it is 1 meter in the minus J direction. Minus 3K means it is 3 meters in the minus K direction. So R cross F is essentially you expanding a determinant of a matrix formed by the vector I, J, K in the first row, then 2 minus 1 minus 3, which is the coefficients of I, J, and K of position vector. So it is 2I, so you have 2, minus J, so it's minus 1, minus 3K, so you have 3, minus 3. Last row is force vector, which is 10, 30, and 20. So if you expand this based on the information we discussed earlier, you will get I times minus 1 times 20 minus minus 3 times 30. So you're just expanding the determinant um, uh, using the method we adopted or discussed earlier. We're going to get the moment of force about O as 70I minus 70J plus 70K Newton meter. Now, the second part of the problem is find the moment of force about x-axis. So we know that by definition, moment of a force about a given axis is UA dot R cross F. So here, UA, which is the unit vector along a given axis, is I because it is x-axis. So the unit vector along x-axis is I dot moment of force about a given point, which is R cross F. We solved that as 70I minus 70J plus 70K. If you take dot product of I dot MO, you get 70 Newton meter as the result. Okay, so if you don't know how to do the dot product of two vectors, I just give some explanations here. So I vector means, which is the unit vector of x-axis, means is 1I plus 0j plus 0k. And moment vector we calculated as 70I minus 70j plus 70k. So dot product of I dot MO equals, you have to multiply the coefficient of i's of I and MO. So that is 1 times 70 plus then 0 times minus 70, the coefficients of J plus coefficients multiplying the coefficients of K. So that gives you the answer 70 Newton per meter. Now another problem. So here is another bracket OAB is given. So you need to calculate the moment about O and moment about moment along an axis OA of a force given. So the force given is 80I plus 40J minus 30K, which is given. Now the position vector is not given, but the geometry is given. Also, the coordinate axis is located at O, which is 5 meters in the J direction. So you get 5J. You are 2 meters in the minus K direction. So you have minus 2K in the position vector of RB. and then you are 4 meters in the positive I direction. So that means your position vector of RB is 4I plus 5J minus 2K. So if you know the position vector of B, which is RB, and the force vector, the moment of force about O is R cross F. So as I mentioned, R cross F is expanding the determinant of a matrix formed by the unit vector in the first column, which is I, J, and K. Then the R vector, coefficients of R vector, which is 4, 5, and minus 2. The last row is the force vector, 80, 40, and minus 30. So if you expand the way we discussed earlier, you get the moment of the force about O as minus 70I, minus 40J, minus 240K Newton meter. Now, calculate the moment along the axis OA. So that is the second part. So along the axis OA, it is very clear from the picture that OA is along the J axis. By definition, if we want to find the moment of a force about a given axis, we need to take dot product of unit vector along that given axis with the moment vector we just calculated. So you get minus 40 Newton meter in this case. And one final question is, again, a bracket is given, and you have given force vector and the position vector of A, where the force is acting, which is given directly. And also it is given as the direction of the unit vector along an axis A. The unit vector along the axis A is given as minus 3I plus 4J divided by 5. The question is to find the moment of this force about O. So we know that it is RA cross F. Then the second question is moment of this force about x-axis. So you have force vector, so you have to take a dot product of I, which is the x-axis, with MO. The third one is moment about a given axis AA. So since the unit vector of axis A is given as minus 3I plus 4J divided by 5, you take a dot product of this with the uh, moment of force about point O. So if you take a dot product, you get the answer for the third question. We will solve this problem in class.